Okay, for this video, I am reading aloud the article that's at the bottom of assignment 1. So you're going to click on this and you can have this open in a separate tab and be reading as I read along. That would be the most effective. Okay, so this article is about the law of conservation of mass. If we look at the first diagram, it says unbalanced chemical equation, and the second diagram says balanced chemical equation. So, what do you think this article might be about? All right. Chemical reactions are occurring both inside of us and all around us every second of every day. As a matter of fact, there is never a time when some type of chemical reaction is not occurring. In these processes, the starting chemical compounds, reactants, are destroyed, and new chemical compounds, products, are created. However, during all of these trillions of chemical reactions that occur each and every day, matter is neither destroyed nor is matter created. But what does this mean? Didn't you just read that compounds are destroyed and new compounds are made during each chemical reaction? Yes, this is true. But during the chemical reactions, the masses of chemicals that reacted will always equal the masses of the products created. This is the fundamental definition of a law that governs all chemical reactions, called the law of conservation of mass. Simply stated, the definition of the law of conservation of mass is conserved and is neither created nor destroyed in a non nuclear change. So that means in nuclear changes or nuclear reactions, this doesn't hold true because in nuclear reactions, a little bit of mass is converted to a lot of energy. So that's a different case. Okay, continuing. The total mass of the reactants is equal to the total mass of the products. The graphic on this page illustrates this point. In the balanced chemical equation, there are the same number of hydrogen and oxygen atoms on both sides of the equation. Matter was neither created nor destroyed during the reaction. It simply changed forms. So, how did early chemists discover that mass was neither created nor destroyed? The earliest Greek natural philosophers postulated that nothing comes from nothing. They knew that matter did not spontaneously appear, but they could not yet fully explain how or why it changed forms. From these early times, scientists used experiments and their keen powers of observation to try to answer these questions. Many early scientists, known at the time as alchemists, worked with various elements and combined them to investigate what was produced. However, the conservation of mass was difficult for early scientists to conceptualize, as many of the gases required for or produced during chemical reactions was difficult, if not impossible, to quantify and measure. The gases were invisible in most cases and would either come from or escape back into the atmosphere. A classic example of this dilemma occurred with the burning of wood. As the product ash has less mass than the reactant wood, it seemed that the mass was lost. It was not until experiments were conducted in sealed containers that scientists began understanding that during chemical reactions, the masses of the starting and ending substances did not change. In other words, scientists began to understand that during chemical reactions, mass was conserved. This concept was pivotal in the process that changed the study of alchemy into what we know as modern chemistry. One of these early and influential alchemists was Antoine Lavoisier, born in 1743, died in 1794, and he is credited with being the first to discover the principle of mass conservation. His experiments were a continuation of the work of Henry Cavendish, 1731 to 1810, who discovered the element hydrogen, though he did not name it at the time. During his experiments, Cavendish discovered what he called inflammable air, hydrogen, and found that this substance formed water as a byproduct of combustion. Combustion means to burn. At the time, both water and air were considered elements. Lavoisier wanted to better understand what water and air were made of, so he conducted very meticulous quantitative experiments. He was careful to measure the masses of both the reactants and products of the chemical reactions that he was working with. Due to his precise measurements, he concluded that although the matter may have changed forms during the reaction, that no mass was lost. As a result of the experiments, Lavoisier identified and named both elements hydrogen and oxygen, and subsequently became known as the forefather of modern science. If you need to hear any of these parts again, you can rewind the video, and then you're going to go over to your Google form and answer the explain question.